Hey everyone, I'm going to do a quick video of this lumen problem. I did one similar to this in class, but I got a couple of requests, so I just want to make sure that I give some clarifications on this. This tends to be can be a confusing topic. Anyway, so it says we have a spherical weather balloon that's being inflated. And so the radius of the balloon is increasing at a rate. So it's increasing, the radius is increasing at 9 centimeters per each second. So it wants to find a formula then for the surface area of the balloon, S of t. So it means I want to be able to input time, okay? And then it says as a function of time, right? I input time, output surface area. So what it's really saying is first I need to find the radius function, and it gives me what surface area equals. Surface area is 4 pi r squared, but I know that r is changing. So surface area is changing as time changes. So let's first look at radius, okay? This is a composition of functions. So radius is changing at 9 centimeters per second. So I input seconds, time in seconds, and I output the radius, okay? Output radius. All right, so I can do two things. I can say, okay, if I input time and I output radius, I can set up an input-output table. So before I start blowing it up, time 0, my radius is 0. After 1 second, well, it's increasing at 9 centimeters per second. This is 9. When another second goes by, it increases another 9 centimeters, 18. It increases 3. I do another 9 centimeters, 27 centimeters. So I can look at this and see that as t changes, change in t is 1, 1, 1. Change in radius is 9, plus 9, plus 9, plus 9. So because my rate of change is constant and I'm adding, I know that this is a linear relationship. So I could actually use these points and come up with the equation for a line, but I can just see that the radius, if I input time, I have 9 centimeters times each second that goes by. So this is my equation for radius. It's changing at 9 centimeters at a constant rate for each second. So this is actually my slope, right? This is my change in r, right? Or change in y over change in x. So my output changes by 9 each time my input changes by 1. So that's my slope or my rate of change. All right. So I've got 9 times t. So I'm going to input time, output radius. Now let's look at my surface area function. Well, my surface area function, to begin with, has a radius in it. So I input radius and I output surface area. So I'm saying I want to take the output of my radius function, and that becomes the input of my surface area function. I'm composing those two functions, all right? But I don't want to have to do two steps. So I want to write it as a composition. So I can say, well, instead of just entering radius, I can put in my radius function. Okay, my radius function is 9 times t. It's a function of time. Okay, so if I say, well, I know that r of t is equal to 9 times t, okay, and I input the radius here. If I want to do a composition of functions, oops, sorry here, this is times t, okay, I'm going to take that radius function, that becomes my input to surface area. So everywhere I see an r, I'm going to put an r of t. Well, what does r of t equal? R of t equals 9 times t. So I'm going to input 9t for r of t. Everywhere I see an r. Now I have the combination of surface area and radius as a function of time. So surface area as a function of time is 4 pi times 9t squared. I hope that helps.